Hello, Advanced Algebra 2. Welcome to the Concept 21 Notes. This is where we explore properties of logarithms. So, look at this table with the properties of logarithms. If you look over on the left-hand side, you can see there are three properties. If you look over on the right-hand side of the table, you would see that these log properties are related to the exponent property. So let's review those exponent properties. They are, if you are multiplying same bases, you will add the exponents. If you are dividing same bases, you can subtract the exponents. And if you're raising a power to a power, you can multiply those exponents. Now look at the properties of logarithms. So we have the product property. If you have log base b of two things multiplied together, you can rewrite it as those two things pulled apart with addition. So log base b of your first multiplier, m in this case, plus log base b of n. These properties also work the other way. So if you have two logs added together, you can rewrite them as multiplication. Our second property is the quotient or division property. So if you have a log base b and the value is divided, you can rewrite those values, the numerator and the denominator, as subtraction. So log base b of the numerator, m, minus log base b of the denominator. And again, these properties work the other way. So if you have two logs subtracted of the same base, you can put them together with division. And then finally, the power property. So if you have log base b of something raised to a power, you can rewrite it, taking that power out front and multiplying it. Also, you can work the other way. So if you see a multiplier out front of a log, you can rewrite it as raised to a power. Now, let's look at example 1. So we're given two values that log base 2 of 3 is approximately equal to 1 and 585 thousandths, and log base 2 of 7 is approximately equal to 2.807 thousandths. So we will use those values and properties of logarithms to evaluate each one of them, rather than putting them on our calculator. So notice in A, we can write log base 2 of 3 divided by 7 using our quotient property as log base 2 of 3 minus log base 2 of 7. Now, using the values given in our instructions, we can replace log base 2 of 3 with 1 and 585 thousandths minus 2 and 807 thousandths. Then when we subtract, we will get 1 and 22 hundredths. Now let's look at B. So log base 2 of 21. Thinking of what we were given in our instructions, we can rewrite 21 as log base 2 of 3 times 7. And then we can rewrite that using our product property. So log base 2 of 3 plus log base 2 of 7. Then using the values that we are given, we can replace those logarithms with those values and then add the values. So that log base 2 of 21 is approximately equal to 4 and 392 thousandths. Now, thinking again of what we were given in our instructions, we can write in C 49 as 7 squared. So log base 2 of 7 squared. Then using our power property, we can pull that exponent 2 out front in multiplication. And then using the value given in our instructions, we can take 2 times 2.807 thousandths for our final answer of approximately 5 and 614 thousandths. Occasionally you will get properties like this, problems like this, where you're given values and then you use properties to use those values to solve the problem. Another thing that we do with logarithms is either to expand them or condense them, and we use the properties to do this. So know that a log expression is expanded completely when there is one log value. And again, I've got this backwards. So an expression is condensed. So that should be condensed. So change that. When there is one log value, an expression is expanded when each log expression has a single variable or number as its value. So we are going to expand. So we're going to focus on making sure once we expand that each of our log expressions has a single variable or number as its value. So let's look at A. We have log base 6 of 5x cubed divided by y. So right away I see division, so I can use the quotient property to rewrite that using subtraction. So I have log base 6 of the numerator minus log base 6 of the denominator. Now, I look at my second logarithm, and that is expanded because that is log base 6 of a single variable. But my first term is not, and so it's 5 times x cubed is the value. So I can rewrite that using the product property. So I can rewrite it as log base 6 of 5 plus log base 6 of x cubed. Now, I notice I only have one log expression that is not expanded completely because my middle log expression is x cubed, not a single variable. But I can use the product property to pull that 3 out front as a multiplier. So I rewrite my first term, log base 6 of 5 plus 3 times log base 6 of x minus log base 6 of y. Now, this expression is expanded completely because all of my logarithms have values of either a single variable or number, so 5x and y. And we use expansion when we take a step further and solve log equations. So let's look at B. I notice that my value is multiplied 3 times x to the 4th. So I can rewrite that using my product property as log 3 plus log x to the 4th. Remember, this is a common log. This is base 10. My second logarithm can be expanded further by taking that power of 4 and pulling it out as a multiplier. And so now I am expanded completely because I have log of 3 plus 4 log of x. So each log expression is a single number or variable. Now I have the natural log of 15x. So I notice that's multiplication, 15 times x. So I can rewrite that using the product property of the natural log of 15 plus the natural log of x. And that's all I need to do to expand because I have a value of a single number of 15 and then a value of a single variable x. So that's just a little experience with expanding log expressions. Now let's talk about condensing. So this is where we are going to use our properties to put the log expressions together until we have one log expression. So right away on D, I notice that they are both log base 4 and it's subtraction. So I can use my quotient property to rewrite that as division. So log base 4 of 7 over 10. Now I wasn't asked to evaluate that, so I'm just going to leave it as one log expression, and that's condensed completely. Now with E, I notice I have multipliers out front of both natural log expressions, so I'm going to rewrite those as powers using our power property. Now I notice that my two natural log expressions are added, so I can rewrite using the product property. So I'll rewrite them as a product. And now I'm completely condensed because I have one natural log expression. Now there's a lot going on in F. I look inside my parentheses and notice that I have two log base 3 expressions that are subtracted. So I can rewrite that as division. And I'll just go ahead and divide. 20 divided by 4 is 5. So I get 2 times log base 3 of 5 plus 1/2 0.5 times log base 3 of 4. Now I notice I have multipliers out front of both of those logarithms, so I'm going to rewrite that multiplier as a power. So log base 3 of 5 squared plus log base 3 of 4 to the 0.5 or 1/2 power. I'm going to go ahead and just do the math there. So 5 squared is 25, and 4 to the 1/2 power is 2. Then I notice that my two log base 3 expressions are apart with addition, so I can use my product property to put them together with multiplication. So log base 3 of 25 times 2, which is 50. So I have completely condensed that to one logarithm. Now there's something important that you should know to help you figure logarithms on any calculator if you're not doing them in your head. So Scientific calculators do not have all bases of logarithms programmed in. They only have the natural logarithms, so base e, and the common logarithms. So don't worry, you can still use that calculator to figure the value of logarithms. So logarithms with any base other than 10 or e can be written in terms of a common or a natural log using what we call the change of base formula. So if log base c of a, you can rewrite that as log base, a different base like b of a, over log base b of c. So let's look at these. On a, log base 5 of 8 can be rewritten as the log of 8, so that's a base 10, divided by the log of 5. So you take the log of the value divided by the log of the base, and we have changed the base to base 10, which is approximately 1.292 thousandths. Now log base 8 of 14, again I can change it to base 10 and rewrite it as log of 14, remember that's base 10, divided by the log of 8, which is about 1.269 thousandths. Now this last one I'm going to change it to base e. I'm going to use a natural log. So I can rewrite it as the natural log of 9 divided by the natural log of 26, which is approximately 674 thousandths. So do not worry if you are working logarithms and your calculator does not allow you to put in any base. Like on A, you're not able to put in base 5, or problem B, base 8, or problem C, base 26. You can use the change of base with either your common log base 10 or natural log base e on the calculator. Now here's an application, and you'll see this formula show up a lot. I've seen it on the end of course assessment for Algebra 2 from the state of Missouri. So for a sound with intensity I in watts per meter squared, the loudness, so L in terms of I, L of I, of the sound in decibels is given by the function L of I equals 10 times the log of the sound intensity over I sub 0, where I sub 0 is the intensity of a barely audible sound, and we will use the value 10 to the negative 12 for that. So find the decibel level of a sound made by each object. So a barking dog. So we'll use our formula, L equals 10 times the log of our intensity, which is 10 to the negative 4, divided by the initial intensity of a sound, which is a barely audible sound, which is 10 to the negative 12. Now just do a straight plug-in on your calculator, making sure to put your log value in parentheses, and then you should get around 80 decibels. For an ambulance, we would expect this to be more decibels than a dog barking, a little louder. So plug in 10 to the 0, and then use your calculator to figure that, and you should get around 120 decibels. So now let's look at C. Let's find the decibel level for a B. So we would imagine that to be less than a dog and an ambulance. So we have L equals 10 times the log of 10 to the negative 6.5 over 10 to the negative 12. Put that on your calculator, and just remember in this formula, this is a base 10 log. So yes, we get about 55 decibels. All right, that concludes our notes for concept 27, looking at log properties and some applications.